All right. So, welcome everybody to yet another lecture in mathematical methods. Okay. So, in this lecture, what we are going to do is we're going to discuss how fascinated mathematicians are with area. Okay. But except we're going to discuss area underneath curves. So, if you have a curve like this, we're going to find this area. Okay. Now, why I say they are fascinated? Because, well, as soon as you learn how to multiply stuff, as soon as you learn that, you know what they do? What they teach you? They start teaching you how to get areas. Okay. If you have a rectangle, that has 3 and 5 as its length, height, and width. They're like, okay, calculate this, and we keep doing that. Not just then; it just doesn't stop. You get different shapes, you get different, many shapes, and then you start doing composites. You do like all kinds of stuff where you break stuff into other shapes. All right, and then you find areas like that. You just don't stop, and not just that. Not just that. You know what else they do? They give you these very sophisticated formulas to get to the area. Okay. We do all of this for area, we get this complex, and yet when we come to something like this, we struggle. Okay, we struggle hard because, well, first of all, let me point it out that it is not a triangle. It is a shape like that, and you're trying to find this area. Okay, so it is not simple because you cannot find any sort of composite shapes. Like you can't make it out of shapes and fit it exactly and then just calculate the area. Okay, that's why it's so tricky. And this is a very basic function. It's like one of the most basic curves. I mean not a linear because it's not curvy, but this is one of the most basic curves, right? And we struggle to find the exact areas. Now, as we did when we found rate of change and we were working with that. When we couldn't find the exact stuff, what did we do? Didn't worry about it. We worked on approximations. Okay, now that's what we're going to do here as well. Okay, so and not just approximate it, we're going to find a range. Okay, we are going to find a range for this area A. We're going to find two numbers that are bigger than the area and one that is smaller than the area. Okay, and we're going to say, well, the area you're looking for is within these two numbers. Okay, and how are we going to do that? We're going to do it like this. So you have your function. Okay, this is the area you need. What we're going to do instead is we're going to make this rectangle and this rectangle. Okay, this rectangle has an area much bigger than the curve. Okay, so this one goes here. So the area actually is less than the big rectangle's area. Small rectangle, much smaller than the area of the curve. So we put it here and we're like, okay, so the area you're looking for, right? It is between the area of the big rectangle, and the area of the smaller rectangle. That is a very intuitive one. But you know what the problem with this is? It should be very obvious. Is that the margin of error is just insane. Okay, like I think it's like twice as much. So not very useful. Okay, I mean it shortens the range down, but still massive range. So what we are going to do instead, right? We are going to break the function down into portions. Okay, so instead of looking at that whole area, we're going to look at these areas individually. Okay, and then when we do the same process there, we find maximum, like bigger values, smaller values. We're going to put that together and then we're going to arrive at a conclusion. Okay, so let's just do that. Like I said, we're going to divide this into portions and look at each portion individually. Okay, so this is your portion in this case. All right, this is not the whole thing, just that portion. And we're going to do the same thing. We're going to find a bigger rectangle and a smaller rectangle. Now, this time we're going to follow a proper procedure. We're going to find, actually I'm going to list the steps down because they are so important and a lot of people miss them. Okay, so to find the bigger rectangle, what we are going to do is we are going to find highest point in the range, in the portion or range. Okay, so in this range, whatever your highest point is, you first find that. Okay, in this case it is this. All right, and then you make that the height of the rectangle. Height of the rectangle. Okay, so we have a rectangle that has a height of this, and then you get the width is equal to width of the portion. Okay, so the width of this rectangle is that. That is your bigger rectangle. That is how you get it. Okay, same thing with the smaller rectangle. Instead of highest, we go with lowest point. Okay, I guess what the aim is to have the entire rectangle basically to be entirely above the curve, and the lower rectangle to be entirely below the curve. Okay, in this case it would just lie along the x-axis, but because that is the lowest point in that range, all right, at 0. But if it wasn't, if it was like a function like this, and that's your portion you're working with, this would be your highest point, so this would be your big rectangle, and this is your lowest point, that would be your small rectangle. Okay, with that demonstration out of the way, we do the same thing with all of these portions, and we get those big and small rectangles. Okay, we get big rectangles and we get small rectangles. Okay, so let me just make them a bit more clear. Right. So you have your big, small, you're doing fine, life is happy. Now you can just find the area, like the total area of these rectangles that are above the curve. Okay, but before we do that, I'll just let you know that because they are above the curve, these are called upper rectangles. Okay, and these ones here are called lower rectangles. Okay, so upper rectangles, lower rectangles. You find the sum of the upper rectangles. Okay, and you find the sum of the lower rectangles. Sum of lower. Now, obviously, the area is then, the area we're looking at is then less than the sum of the upper. Okay, I'll just write that in a better notation. Okay, all right. So I just have to rewrite it. It's not an option. Yeah. So the actual area is greater than the sum of the lowers. Okay, as you can see, and is less than the sum of the uppers. Okay, and there we have it. There we have a range for the area we're looking at. Okay, by using a bunch of rectangles. This is the process that we use to approximate that area. We now have a range. Okay, let's do an example because this is what you'll be doing for now. All right, I just want you to be very, very used to this, and then we'll talk about some problems with this method, but that would be later. We have to drill this down and get very, very easy and comfortable with it because it's really just rectangles. Okay, we cannot mess these parts up. So if we have our curve like this, okay, same function, just to keep it simple, all right, and I want you to find the area from 0 to 4 using 4 rectangles. Yes, the question is what determines the number of rectangles. Okay, using 4 rectangles, I want you to find the range for the area. Okay, now I want you to give that a shot yourself. Okay, just put in like in the answer, just put in like the median value. So if you get like area is between 10 and 20, you find the average between these two, 15. All right, and that put that out into the answers. All right, And if it's correct, it's correct. If it's not, we're going to go to the solution. That's fine. All right, so just give it a try and see how you go. All right, so I hope you gave it a very good and fair shot. We are just going to jump right in. Okay, so first of all, to draw the rectangles, we have to decide their dimensions. Okay, obviously the height would be chosen later on, but we need to know their widths. Okay, we need to divide this into 4 equal portions because there's going to be 4 rectangles. Okay, so to divide it into 4 portions, we just go total width. Okay, so because it's from 0 to 4, the total width is 4, divided by number of rectangles. Number of rectangles, okay? And then you get this, you get 1. Okay, so the width of each of the rectangles is 1. Okay, so this would be your, oh, spoilers, this would be your portions, okay? Now, we do the same process as we did last time. We'll go with the sum of the upper rectangles, okay? I'm just going to abbreviate that to area upper because it's the area of the upper rectangles, okay? Area upper, and that's how you should be notating it in the test and stuff. Okay, area upper is equal to length times width of each of the rectangles that you find, okay, in this region. Following the steps, for the first rectangle in this region, that is the highest point, so we make that the height, and then that becomes the width, okay? In this region, this is the highest point, make that the height, make that width. This region, this is the highest point, make that height, make that width. Highest point, height, width, okay? So, now that we have our heights, we can use the formula for area, find the area of all of these rectangles like this, and happy days, okay? Simple stuff. So let me just get rid of those because, it will be easier to draw the other ones when we get to it. And blah, blah, blah. All right, so we get f of 1 because this was the height, okay? And the width is 1, plus 1 times f of 2 because in the second portion this was the highest point, plus 1 times f of 3 because in this portion this was the highest point, plus 1 times f of 4 because in this portion this was the highest point. And let's just calculate that really quickly, okay? We get 1 plus 4 plus 9 plus 16, which happens to be 30 units squared, okay? Now we do the same thing with the lower sum, okay? Area lower. All right, actually I'll use a different color, sorry about that. All right, area lower. Yep, correct. Right, so area lower, we find the lowest points in each of those ranges. This one, this one, this one, and this one. All right, and then we do the same thing as before. The width is constant. F of 0 plus 1 times f of 1, blah, 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 blah. On it goes, okay? What I should note is that the 1 here is common because all of the rectangles have the same width, okay? That's where the 1 comes from. And we made them have the same width when we divided it here, okay? So they have the same width, we factor out the width as common, and we are left with this inside the bracket, okay? So all the lowest points in each of the ranges, okay? So in the first range, this is the lowest, second range, this is the lowest, on and on, okay? You get the gist. And then you just do some maths, crunch some numbers, you get your answers like such, okay? You get 14 units. And there you have it, as simple as that, your upper area and your lower area. So you say the area is less than upper, less than upper, greater than lower. Therefore, your area is between 30 and 14 units squared. Okay, there you go. It is a very simple process, okay? It is not a complicated process, I promise. It is just that, okay? So practice it very nicely, okay? You don't have to practice it too much, but don't make a mistake here, okay? It's a very simple thing. And once we do that, we will look at this issue here, that the margin of error is still pretty massive. Okay, so in your next lecture, that is what we're going to look like. Just a heads up, I want you to be very, very good at this because you're going to need it. Okay, good luck.